Hi guys, in this session I will explain singleton design pattern. What is singleton? Singleton is a design pattern that ensures a class has only one instance. It means a single object creation. Okay, it is commonly used in the scenarios where a single shared resource such as database connections, loggers and configuration managers and utility methods. Okay, the singleton, so we can write the code in two ways, eager loading and a lazy loading. Let me write the code and I will explain you. This is the code. Okay, let me explain the code. See here, I am declaring as a static single instance and initializing with null and private constructor. So why I am creating as a private constructor? Suppose if I create public constructor, okay, so what will happen? From other class onwards, if we call directly this class object, it will create. Okay, if someone again it will create the new object, right? Here what is happening, if we declare as a public, the singleton it is break, right? So that's why I'm creating as a private. Okay, yeah, now I'm declaring as a one static get instance method. Okay, here I'm checking either instance is null. If instance is null, then only I'm creating the object. If it is not null, then directly I'm returning the object. This is very simple code. Okay, let me call this code from the tester class. Okay, so see here I'm calling the instance, I'm calling this get instance method. So what will happen, it will check the instance is null. If instance is null, then it will create that object and it will return. Okay, the second time I am calling, so what will happen, it will check the instance is not null, then directly not null, right? Then directly it will return the instance. Okay, the same always, whenever you call the get instance method, it will return the same instance. Always it will return the same instance. I will show you the proof. Now I am calling the twice, the same method I am calling the twice, and we will check object is same or different with the help of hash code, and we will check the two objects either both are same or not. Guys, you see here object 1 hash code, object 2 hash code, object 1 hash code and object 2 hash code printing here, and you see both are same. Yes, both are same. You see, guys, you see here both hash code are same, both objects hash code same. It means both objects are same. You see here it is true, object 1 double equal to object 2. Yes, it is true. Okay, even I call third time also it will give the same result. You see here object 3 hash code, we will check. What is the object 3 hash code, we will see. So if you call multiple times also, it will return the same instance. You see here object 3 hash code, the same, right? The instance is same. That is fine. As of now we are good. Okay, after completing, this is very easy code. You see here whatever we written, this is very simple and very easy, but questions it will come. The interviewer, he may ask the cross questions. Okay, what are the cross questions? Cross questions are very important in the singleton design pattern. So these all are the cross questions interviewer he will ask. Okay, the whatever you've written the code, will it work in multi-threaded environment? Answer. Okay, this is the code you have written. Will it work in multi-threaded environment? No, it won't work. This is one question it will come. Second question, will it work in serialization? No, it won't work in the serialization. Singleton, it will fail in the serialization. This is second question. The third question, suppose if I clone that object, okay, see here object came, right? So object 1 dot clone, if I clone, or object 2 dot clone, so both objects are different, right? So will it work? No, in clone time also it won't work. Singleton, it will break. Okay, the fourth question, suppose this is the private constructor. Using Reflaction API, I will make to public. Then this singleton, will it work? No, singleton, it won't work. It will fail because using Reflection, so it will change it to public. So once we make the public, then what will happen? If you call the constructor, then object it will create. So how many times you are calling the objects? That many time objects it will create. So singleton it will fail. So these are the scenarios singleton it will break. Okay, now we'll go one by one. So how to resolve those are the very important, those are the cross questions. So interviewer he will ask. Okay, so we'll go first questions. This question, okay, he will ask, so in multi-threaded environment it will break, what you will do? The solution is this one. So simply what you will do, you will add the synchronization to here. Okay, before coming that, I will explain why it won't work in multi-threaded environment. So why need synchronization block? Okay guys, you see here in multi-threaded environment, okay, assume here we have multiple threads are executing on line number 11, T1, T2. Just take two threads are checking at the same time. Okay, what they are checking, instance is null. T1 it is null, then it will come into line number 22 and it will create that object. Okay, at the same time T2 also checking, instance is null. T2 also it will come line number 12 and it will create that object. How many objects it is created? Two objects it is created. Singleton failed, it's broke. The singleton the rule it's broken, right? So singleton is failed. So what we have to do, we have to add the synchronization block. Okay, the synchronization block. Now got the synchronization block. Okay, and again interviewer he will ask the one more question. The code is, the performance wise this code is good or not? What are the problems you will face? Let me explain how problems will come first. Okay guys, you see here, after writing this piece of code, interviewer he will ask this question. This code is absolutely works, but it will give the performance issue. What is the solution? Answer is double checking. Okay, so how it will give the performance issue? First you understand that, then you will give the solution. Okay, let me explain the problem clearly. Okay guys, you see here we have added the synchronized block here, right? Synchronized block. So whenever we added the synchronized block, so multiple threads, right, it won't allow inside this block. Suppose assume we have the n number of threads it is coming into the synchronized block, so those number of threads it will block here only. Suppose just assume we have 1000 threads, just assume 1000 threads it will come. First T1 it will come and it will enter T1. Okay, T1 it will enter and T2 to T1000 threads it will wait into synchronized block at this level, line number 11 it will wait. Okay, so after completing this T1, I mean after completing of after creating object for singleton by T1, then what will happen, that T1 thread it will come out from this synchronized block. Okay, it will come out from the synchronized block, then it will return the instance. Then T2 thread has a chance to enter into this block. Okay, now T2 thread it will check, now T2 is here, it will check instance is null or not. No, instance is it is not null, it is already created by T1, right? Then it will return this instance. Okay, now T2 is come out from the synchronized block. Now T3 has a chance to enter the synchronized block. Now T3 what it will do, it will check instance is null or not. Instance is already created by another thread, right? So what will do, just it will come out from here. I mean it will come out from synchronized block and it will return the instance. Okay, now you see guys, all threads up to 10 how much it is, 1000 threads are in queue, right? The synchronized block it will acquire the lock, so they are in queue. So all threads one by one it will come, it will check, one by one it will come. T3 it will come, it will check object is available, I mean instance is available, then it will come out from this synchronized block, and again T4 it will come, okay, T4 it will come and it will check Okay, T4 it will go out, again T5 it will come like this, right? So up to 10,000 threads it will be in the queue. That is the issue, that is the performance issue, that it is there in interviewer brain. That is the question he is asking. Okay, that is the question, that is the performance issue. So what is the solution, how you will achieve double checking? So just by adding double checking. So what you have to do, add this piece of code, double checking, and how it works we have to explain. Okay, guys, this, take one more example. Okay guys, in this example, so the same time T1 thread is entered synchronized block and it is checking, and now it is in the line number 14 and it is creating the object. It is creating that object and created also. Okay, at the same time T2 block at the line number 12 and T3 to T1000 this many threads at line number 11. Okay, the T1 thread, what happened, T1 thread, it is created the object single instance, and it will come out from the synchronized block. Then at the same time what will happen, T2 will enter, right? T2 it will enter, T2 it will enter and it will check. At the same, guys, you see here, where is the T3 to T1000? T3 to 10,000 threads are at the line number 12. So T2 also checking instance equal to null, and at the same time these threads also it will check. But instance is available, right? This instance is available, instance is already created by T1. So T2, for T2 it is already available. This condition it will fail and it won't go to the if block to create objects. And this threads also, T3 to T1000 threads, it will check. So all threads it will fail, no need to be in the queue. Here no need to be in the queue, because this is if block. If it is there line number 12, then it should be in the queue. But if it is in the if block, no need to be in the queue. Okay, there is no lock here, synchronized only it will lock. Okay, so all T3 to T1000 threads it will come out from this if block and it will return the instance. So that's why double checking is required. You are clear? I hope you are clear. Okay, now this is the double checking. Okay, double checking is over. Let's go for another question. Okay, again interviewer, he will ask the one more cross question. Okay, you see this. Okay, so you see here, in here, right, we need to mention volatile in the multi-threaded environment. So sorry, whenever you are writing in the multi-threaded environment, so you need to write the volatile. Okay, he may ask the question, what is the significance of volatile? Why you are declaring as a volatile single instance? What is the use? Suppose if I am not using volatile, what will happen? These are all cross questions, it will come out. So you have to answer those questions. These all are the cross questions. Okay, volatile important, I will explain. Guys, you see here, this is the piece of code, right? Okay, this piece of code. Okay, I am declaring as a volatile. Why it is volatile? So before going to understanding the volatile, first we need to understand the volatile keyword. What is the volatile keyword? How it is useful? Okay, yeah, volatile keyword I will explain first. Then I will explain what is the significance of volatile in this singleton. Okay, guys, volatile, what it will do, it will prevent the instruction reordering. It will prevent the instruction reordering. It means it will give visibility guarantee. This is the terminology you have to use, visibility guarantee, visibility guarantee. Okay, these are the terminologies. So it will prevent the instruction reordering. It means it will give the visibility guarantee. What is the meaning of that? Guys, you see here, this is the original code. This is the original code. Int a equal to 5, int b equal to 10, c equal to 0, and you have given the 3 instruction. Instruction 1 is this one, and instruction 2 is this one, instruction 3 is this one. Okay, you have given the 3 instruction. What is the instruction 1? C equal to a plus b. But a is depending upon line number 181. You see, a equal to a plus b, right? It is depending upon another line. Instruction 3. Instruction 1 is depending upon instruction 3, and instruction 1 is depending upon instruction 2. Right? It is depending, right? So compiler sometimes, not always. Okay? So what it will do, it will change the instructions. It may change, it will not, it may. Okay, remember this, it may or may not. That is depending upon the compiler. We cannot predict. Okay? So you see here, suppose the compiler, it's reordered the instruction, what will happen? You see here. So if assume the reorder the code. Okay, you have given this original code, and the instruction it will change. You see, instruction, this b, where it is, this is actually original code is instruction 2, but it came into the instruction 1. It came to the first. Okay, and this instruction, okay, in the originally, which instruction, this is the second instruction now, originally where it is instruction 3. You see here, instruction 3, but now it is instruction 2. Okay, now see, if you see here, this is the third instruction, originally where it is instruction 1, right? After reordering by compiler, so what is the code? It will be like this. Okay, this is the instruction reordering. I hope you are clear this one, right? So what is the volatile use? It will prevent the instruction reordering. It means it will give the visibility guarantee. What is instruction reordering? Suppose whatever we give the instruction, right, the compiler, it will reorder the instructions. You see here, I have given the 3 instructions. You see, after reordering, it will come like this. This is meaning of instruction reordering. So compiler, it may reorder. It may or may not. Not sure. We are not sure. Compiler, it will decide. Okay. Now you are understanding the instruction reordering, right? Now we'll go to here. What? Okay. Now we'll go to, guys. So in the singleton, we are using the volatile. Okay. Before going to volatile, so we need to understand object creation steps. We already understood instruction reordering. Okay, instruction reordering we already understood. Suppose if we use volatile, what will happen? This instruction, it won't change. This instruction, it won't change. Okay. If you mention this as a volatile here, instructions, it won't change after decompiling also. Okay, you can, once you decompile and see, whatever you give the original code as it is, it will give. Okay, it will prevent. That is the use of the volatile. So what is the volatile uses? Instruction it prevents the instruction reordering. Okay, suppose if you want declare as a volatile, then instructions, it will change. Definitely it will change. Sometimes it will give an issues also. You are expecting something and it will give the output something. Okay, that is the problem. Okay, before going to that, so what we are working on? We are working on the singleton, right? We are creating the object. We are creating the single object. Okay, we are creating the single object. Now, what are the steps involved to create a objects? Creating the objects, the few steps are involved. Guys, I will explain in very easy. Suppose you are creating the object for employee class. So what are the steps it will involve? I will explain. Suppose if you are using the new employee, whenever you are using the new means object allocation. So JVM, what it will do, it will allocate the memory for new objects. JVM, it will understand whenever you are using the new keyword, JVM, it will understand you are creating the new object. What is the object? Employee object. Okay, so for that, it will allocate the memory. This is the step 1. You can assume instruction 1. Okay. After second step, what is the step 2? So you are using you are creating the employee object by using new keyword. What are the parameters you are passing? These are the parameters you are passing: name, id, something, salary you are passing. Okay, just take only 2, that is fine. Just 2 is fine, name and id. Okay, the second step, what it will do, it will execute the constructor to set the values, to initialize the values into the object fields. It means, suppose if you call this object, what will happen? So suppose if this is the employee class, this is the employee constructor, name and id, you see here it is initializing name and field to the class level variable. Okay, this is the second step. Suppose if you are not passing this one, what will happen? The default constructor it will call, right? If you call the default constructor, you are not passing anything, but you have the instance variable, it will assign with the default values. That is the step in step 2. Okay, now step 2 is over. The step 3 is object initialization. So it will create that object and it will give the reference to this object. What is the reference here? emp is the reference. Now 3 steps. What is the 3 steps? First, whenever you are using the new means new object creation. For creating a new object, it will allocate the memory. First step. Second step is it will call the constructor and it will initialize the fields. Second step. Third step is it will give the reference. These are the 3 steps. 3 steps means 3 instructions. Assume 3 instructions. Okay guys, 3 instructions. Keep it in your brain, don't forget it. Now come here. Okay, come here. Okay, T3 to 1000 threads it is available, guys. So now I am not using the volatile. What is the problem will come. First I will explain the problem, then I will give the solution. Okay guys, you see this code, thread T1 at line number 13, thread T2 it's available in line number 12. Okay, thread 3 to 1000 threads it's available, it is there at line number 11. Okay, it's there in this line. Okay, now T1 thread, so it is creating the object, it is there in line number 14. T1 is at line number 14 and T2 is 12 and line number 12 and T3 to T1000 is line number 11. Now T1 is object creating. Okay, object creating, it is in middle. Okay, it is in middle. Okay, now copy this, that is the original instruction. Okay, instructions reordered. Okay, instructions reordered by compiler. Okay, this step 3 it came into the step 2. Now this is step 2, this is step 3. Instruction 1, instruction 2, instruction 3. Okay, now 3 instructions. Originally these are the steps to follow compiler, but compiler sometimes what it happens, right? So it may change the instructions. Okay guys, you see this is the original instructions it should follow, but due to instruction reorder, so compiler it following the steps. Okay, now you see here, where is the T1 is trying to create that object, it is in middle. T2 is here, T3 to T1000 it is here. Okay, the T1 thread come here. T1 thread step instruction 1 is completed. Yes, it's allocated the memory and and T2, instruction 2, what it is happening, it is giving the reference. So it is giving the reference, but object is not constructed with these values. Actually these values when it should construct here, but before that only it given the reference. keep it in your brain. Okay, now you have the reference you have, you come here. Okay, t1 reference it given. Okay, and it came out from this. Just assume it is here only. Okay, reference is ready, and t3 thread, it is checking instance is null or not. No, instance is not null, because instruction 2 it is already over. It means it's given the reference. Instance is not null. Instance is not null. Okay, you see here, it will give the reference. It will give the reference that is partially constructed. These values it is not yet set. Okay, but reference is given. So what will happen in this condition? Condition is false, it will return the instance. Okay, suppose if you call this instance dot name, the name it won't available. It will give null. Even it won't give null, because that is partially constructed object. So we can call that is off-breaking object. Okay, off-breaking object. For this, all T3 to T1000 threads are partially constructed. That is the problem. So that is the issue. That is the problem. Whenever we are not defining, whenever we are not declaring as a volatile, that is the problem. So object is not fully constructed. It is partially constructed due to the instruction reordered. Due to instruction reorder, it is partially constructed. Construction execution, it is not completed. For T1 still it is working on this, but before that only all threads have the references and it returns. Okay, that is partially constructed object. So what we have to do, that is the problem. So what we have to do, this is the original instructions, right? So this is the original instructions. It shouldn't reorder the instructions. For this, what we have to do, we have to define as a volatile. If you define as a volatile, whatever you are giving these instructions, it won't change. You see here, this constructor, this instruction 2, step 2, now after reordering, it is in step 3, right? So these instructions, it won't change. Okay, that's why we need to declare as a volatile. Okay, this is one more cross question. This is very interesting also. The interviewer, they will ask this kind of questions in Singleton design pattern. So this is over. Okay, now we'll go for another question. Multi-threaded environment is over. This piece of code will work in the serialization. Will it work in the serialization? No, it won't work. It will break the serialization. Okay, let me write the piece of code. I already written. Let me copy and I will explain. I think I'm not written. Okay, just implement serializable. Guys, you see here, this code, it works in multi-threaded environment. Everything we have taken care. And now in the serialization time, suppose if we do the serialization, okay, then it will break. I will show you the proof. The question it will come. I already shown you, right? The interviewer, he may ask the questions. Will it work in the serialization? Answer is no. I will show you why it won't work and what is the solution also. Okay guys, come down, scroll down. Yeah, okay, this is the object. This is the Singleton code. Now I'm calling this get instance method. Before that, let me explain this piece of code. I am serializing which object? This object, instance 1 object, and after that I will deserialize. After deserializing also, the same instance it should be there, right? It should be there in the same. How to check either same instance or different instance using the hash code? Okay guys, you see here, using file output stream and object output stream, I'm writing this instance. Okay, then I'm closing. Now after closing, what is the hash code of that object? I'm checking. While serializing time, I'm checking the instance of hash code. After deserializing, also I am checking the hash code. This is the piece of code for deserializing. So file input stream, object input stream, then instance. That instance I am checking the hash code. If the hash code is same means object is same. Hash code is different, it means hash code is different means object is different. You see, instance 1 double equal to instance 2. If it is both are same, it will return true. It both are not same, it will return the false. Guys, you see here what is the code? This is the code. So I'm trying to participate in the serialization. That's why I have implemented the serializable. Now you go for this one. Guys, you see here. So serialization time, single instances, this is the hash code. After deserialization, this is the hash code. Both are same hash code? No, both are not same. So singleton is breaking here, right? Singleton is breaking here. So what is the solution for this? So we need to add read resolve method. So there is one method, read resolve method. So we need to add. So this one, not this one. Yeah, this one. Okay, I am adding this piece of code. Read resolve method, it will resolve the issue. Which method? This method, read resolve method. Okay, now you go and check the same code. I am serializing and deserializing and checking both instances are same or not. Using hash code also you can check, directly also you can check. Guys, now I am running this and we'll see. You see, before serializing, this is the hash code. After deserialization, this is the hash code. So both instances are same. Yes, both instances are same. You see, right? True. Okay, this is also over. Okay, now which questions it will come? I already written this list of questions, right? So this is also over. Okay, now we can come to here, the clone. Okay, will it work in the clone? Suppose this is the object 2. So what I will do, object 2 dot clone, something I will return. So what it will return the new instance, right? New instance means new object it will give. Here also it will break the singleton instance, I mean singleton design pattern. So it will break the singleton design pattern if we clone the object. Okay, let me show you what piece of code we have to write. So we have to implement clonable and override the clone method. Okay, we have to implement clonable and we have to override this method. Okay, suppose whoever call this clone method, what it will do, it will throw an issue, clone not supported exception, it will throw. Okay, and okay, now up to here 3 questions. One more questions it will come. What is this question? What is the cross question? So interviewer, he will ask, suppose using Reflaction API, if I'm using Reflaction API, so I'm changing this to public, the constructor, private constructor changing to public constructor. Then other persons, they can call this singleton constructor and they will create n number of instances. That time also it will break, right? That time also it will break. So in that time, what you have to do? So you have to write a logic, your logic. So let me show you what is that. This is the one way you can write. Okay. Okay. Suppose by using reflection, if anyone made this, I mean anyone modified this private to public constructor, public modifier, then they will, if they call this singleton constructor, so first it will check the instance is not equal to null. If instance is not equal to null, then what will happen? It will throw an issue. because it is already created when whoever calling the get instance method, that is already created, then it will check it is not null. If it is not null, then what we are doing, we are throwing the issue, we are throwing the runtime exception. This is one way. Okay, this is one way. So we can avoid the reflection. So we cannot avoid private to public modifying, changing, but we can apply the logic, this logic. Okay, there is one more effective way, that is for enum. I will write the piece of code also. Instead of the class, instead of this class, so you can use this enum. Okay, so I will show you. Okay, now you guys, you see here I have declared one instance, this one. Okay, and I've written something method, so I need to call, assume you are, this is the utility method. Okay, this is the utility method. You are calling in multiple places. You need to call multiple places with single instance. So come here. So first what I'm doing, I'm creating the two instance and check the hash code, single instance 1 and instance 2, either both are same or not, then you can call. That's your choice. Okay, now you see here, so I am not using the class here, I am using enum. Okay, this is the best approach, effective way. You guys, you see here, both hash code are same. You see, right? Both instances are same. Yes, true, it is true. Let me show you the code. Instance enum, just I declare this instance. This is utility method. As for your requirement, you can write. Suppose if you want to write validations, that's your choice. Okay, and the same, suppose if you want to participate this in serialization, you can do. Let me show you the piece of code also. Okay, the same tester class, single instance is the same. Now I'm changing this. Now I will test this one. So what I am trying to do, I am creating the instance here and I'm serializing here, and after that I'm deserializing here. After deserializing, I am checking both instances are same or not, then I am calling the my method, this do something method. Okay, yeah guys, you see here both instances are the same. I am checking using double equal to operator, so it is returning true, and I am calling this method. See, if it is not null, then this method I am calling. Okay, I hope this session is very useful. Thank you, thanks for watching.